I'm Saranda Poddar, and today I'll be presenting and explaining CovidXAI, Explainable AI assisted web application for COVID 19 vaccine prioritization. My co authors are Deepraj Chowdhury, Soham Banarjee, Riya Pal, Abrar Gani, Caroline Ellis, Rajesh Chand Arya, Sukhpal Singh Gill, and Steve Uhlig. This work has been published in Internet Technology Letters by Wiley. The contents of this presentation are introduction, our contributions, proposed methodology, which has been further divided into three sections, which is dataset, machine learning models used, and explainable AI. The last parts of this presentation are results and conclusion and future works. Introduction. Now, in a large country like India, which has a very high population density, besides social distancing, strategic vaccine distribution is needed to achieve herd immunity. Now, the objective of this work is to build a web application that helps to identify the more vulnerable masses in receiving the vaccines so that the spread of COVID can be controlled. Now, previous research works investigate correlations between either increased age or other health parameters, comorbidities, and other health conditions, or healthcare worker status to the severity of the COVID infection. But none of them combines all of these factors at once to predict the risk group of an individual. Now, our contributions are a model to build to predict the risk group of an individual, which is based on the risk factor. And the risk factor is further classified into low, medium, or high risk group. Now, COVID XAI is built on a dataset which consists of 24 factors, which includes health, age, health parameters, age, diseases, disorders, healthcare worker status, etc. Further, a web application is built or developed to offer an interactive user interface. Further, machine learning has been used to predict the risk group of an individual, and explainable AI is used to show the contribution of each of the parameters to the model prediction results, and so the machine learning model is further justified and made transparent. Proposed methodology of this work is a prototype which consists of a machine learning model which runs at the back end of a web application. Firstly, in the front end or the in the web application, the user is asked to enter a series of data such as age, his or her various health conditions, the user's gender, if he or she is a frontline worker or not, and these are the factors which are used to train the model. Now, this data which is collected from the user is collected at the front end of the application, which is fed to the trained machine learning model, which is in the back end, which is hosted in the cloud, as we can see in the figure. The trained model processes the data and helps in predicting the risk group of the user, which is classified as low risk, medium risk, and high risk. And this prediction is then sent to the front end of the application, which is displayed to the user. As previously said, to justify how the model is working, XAI or explainable AI has been used to show the varying impact of each of these attributes, such as age, the various health conditions, gender, etc., on to train the model on the output. The dataset which has been used to train the machine learning model is collected from 2,512 individuals. This training data has a total of 24 attributes upon which it is based. They are gender, pregnancy, age, cancer, Down syndrome, COPD, heart condition, sickle cell, BMI group, antibody test, immunocompromised state, smoking, type 2 diabetes, asthma, type 1 diabetes, hypertension, liver disease, frontline worker status, chronic kidney disease, cerebrovascular disease, neurological disorders, pulmonary fibrosis, thalassemia, and decompensated cirrhosis. The target group or the risk group is based upon the values of these 24 variables. The resultant risk factor is calculated as a decimal between 0 and 1, which is further classified into three categories. Low risk is zero point 0 to zero point 0.4, medium risk is 0.41 to 0.7, and high risk is 0.71 to 0.99. The dataset for the experimentation or for which has been used in this work can be accessed from this link at github.com slash Deepraj 2001 slash COVID vaccine. The machine learning models which have been used to train the model are random forest and XGBoost. Now, random forest is a supervised learning algorithm which makes use of an ensemble of decision trees, which further leads to more accurate results than a single decision tree. This dataset has a high number of parameters, so the risk of overfitting is more. The accuracy of the random forest model achieved is 85%. Now, to get better results than the random forest model predictions, we have used XGBoost. It is a faster ensemble classifier than random forest, and XGBoost uses the gradient boosting framework, and it uses classification and regression trees where each node contains a score instead of a single decision, which leads to better results of the model. And the accuracy of this model is 87%. Explainable AI. As we previously said, explainable AI is used to explain the working of the model and to make the model results clearer. Now, XAI helps to explain the working of machine learning models. Simply put, it shows how the model predictions change if we change the value of a single feature. Now, for this work, the use of Shapley values have been made to implement XAI. Now, what are Shapley values? Shapley additive explanation or SHAP are a measure of the feature importances and is a method to explain individual predictions. It is based on the game theoretically optimal Shapley values. Its goal is to explain the prediction of an instance by computing the contribution of each feature to the prediction. As we can clearly see, these are the feature importances of the random forest model, which is to the left, and the XGBoost model, which is on the right. For example, we can note that the feature age has more importance in the random forest model than the XGBoost model, and whereas the feature antibody test has more importance to the XGBoost model predictions than the random forest model predictions. And this goes respectively for each of the 24 factors which have been noted in the figure. These are the explainable AI graphs. And these figures show the impact of each factor to the prediction of classes 0, 1, 2. Class 0 corresponds to low risk, class 1 corresponds to medium risk, and class 2 corresponds to high risk. We can clearly see the varying impact of the feature of each of the features in the respective class predictions. Results, we can see from the table all of the performance metrics of both of the machine learning models used, and we can clearly see that the accuracy of the random forest model, maximum test accuracy achieved in the random forest model is 85%, and that of the XGBoost model is 87%. We can see the precision recall and F1 scores of both of the models from the table. Conclusion and future works. Mass vaccination has been found and proven to be the most effective method to controlling this pandemic, especially in highly populated countries, which are still facing a significant shortage of vaccine doses. Now, CovidXAI serves as an effective solution to this problem by identifying the risk groups of the population and thus administer vaccines to them respectively. COVID-XAI helps to allocate more vaccines to the more vulnerable population, thus reducing mortality, helping achieving herd immunity faster, and preventing also the virus from spreading faster. It has been aimed now for this work to get better results. It has been aimed to add more features to make better predictions of the risk groups and hence further increase the viability of the model. Now, to increase the accuracy of the model, and to further increase the efficiency of the prototype, deep learning algorithms can be used to get better results. Then User accessibility can be improved by making a mobile application for Android and iOS devices by utilizing the concept of Internet of Things. Thank you.